Okay, this is Computation with Fractions revision video for Year 7. In class, we actually went through this column the other day, but I'm going to start on this other column here, and then at the end of the video, I'll go back through this column in case there was anyone that was not in class that day. So I'm going to start with this column over here. So what we're doing here is subtracting these fractions. Now we know that we cannot just subtract the fractions because the denominators are different. So when the denominators are different, just have a quick look as to whether the denominator of one of the fractions can be changed easily into the denominator of the other. And if it can, then what you can do, you can say, right, I can count up by 3. I know that 3 goes into 9, so I can go 3, 6, 9. I know that 3 times 3 will give me 9. So what I want to do is change the denominator of this second fraction to a 9. So my first fraction is still 7 over 9. And with my second fraction, I'll be multiplying the numerator, the denominator and the numerator both by 3. So 1 times 3 is 3, and 3 times 3 is 9. So now that I look at this question, I've got 7 over 9 minus 3 over 9. Now the denominators are the same, so therefore I can just subtract the numerators. So 7 minus 3 is 4. Okay, now looking at the second question. Now obviously the denominators are not the same, so you do not just go and add the tops and the bottoms. What we need to do is make both denominators the same. So there are a few different ways of doing this. Look, the simplest way to do it, we know that 6 doesn't go into 8. The simplest way to do it, or the quickest I suppose, is to multiply this 6 by the 8 and that 8 by the 6. When we do that, however, sometimes the denominator that we get won't always be the lowest denominator. So what I'm going to do, I'm going to multiply this 6 by 8. So if I'm multiplying this 6 by 8, I have to do 5 times 8. And what I'm also going to do, so that the denominators will be the same, I'm going to do 8 times the 6 here. And I also need to multiply the numerator by 6. So 5 times 8 is 40 over 6 times 8 is 48 plus 3 times 6 is 18 over 8 times 6 is 48. Now what I've really done here, instead of having 5 sixths plus 3 eighths, I've made both fractions out of the same denominator. So I've created some equivalent fractions. But the important thing was to make sure that these fractions had the same denominator. Quickest way of doing that, if one denominator does not go into the other, is to do this denominator times that one and that times this. So if you multiply the denominator by 8, you must multiply the numerator by the same amount. And same over here, multiplying this denominator by 6, multiply the numerator by the same amount. Now that the denominators are the same, we can add the numerators. 40 plus 18 is 58. Now both those numbers are even. So what we can do is divide them both by 2 because they're both even numbers, and we're simplifying now. Half of 58 is 29 and half of 48 is 24. Now we know that we've got an improper fraction because the numerator is bigger than the denominator, and we know that 24 out of 24 is 1 whole. So we've got 1 whole and we've got 5 bits left over out of 24. Okay. The other way you could have done this question, instead of making the denominator 48, the actual lowest common denominator is 24. So you could have, if you want, make both denominators into 24 by multiplying this one, the 6 by 4, this fraction here by 4 on 4, and multiplying this fraction here by 3 on 3. But however, if you did do 48, it will still work. Now let's look at this next one here. Our denominators are not the same, so therefore we cannot add the fractions together. So what we're going to do, 3 times 4 and 4 times 3. So if we do 3 times 4, down on the denominator, we have to multiply the numerator by 4 as well. And over here, we said we were going to multiply this one by 3. So whatever you do to the denominator, you must do to the numerator. So this becomes 2 times 4 is 8 over 3 times 4 is 12 minus 1 times 3 is 3 over 4 times 3 is also 12. Now that the denominators are the same, we can just subtract the numerators, and 8 minus 3 is 5. Now this cannot be simplified. So our answer here is 5/12. Now we're going to come down to the bottom of the page here. And we're going to look at adding and subtracting mixed numerals. Now when we do these questions, the easiest thing to do would be to add the whole number parts and we get 3. And then we're going to add the fraction part. So, sorry, if I add the whole number part, sorry, I get 2 plus 3 is 5. But I still need to add the fraction part. So I'm just going to do that down here. So I've got 3/4 plus 1/6. So I just want to do that bit separately. And when I add the 3/4 and 1/6 and I get my answer, I'm going to put it back up here. Okay, so I've added my whole number parts. 2 plus 3 is 5. Now I want to add my fraction parts. Now I need to look for the lowest common denominator. Now some of you will realize that the lowest common denominator is 12. Otherwise, if you can't work that out, because both 4 and 6 go into 12, the other way of doing it is to multiply the 4 by the 6, and I'm going to multiply the 6 by 4. So this way, I know my lowest common denominator is going to be a little bit big, it's going to be 24, but this is probably the easiest way for you to do it. So 3 times 6 is 18, 4 times 6 is 24, plus 1 times 4 is 4, and 6 times 4 is 24. So what I've done is I've changed my 3/4 and 1/6 both into fractions that are out of 24. That way, now that the denominators are the same, I can just add the numerators. 18 plus 4 is 22. Now, because 22 and 24 are both even, I can simplify this fraction by dividing the numerator and the denominator by 2. And 22 divided by 2 is 11, and 24 divided by 2 is 12. So my answer is 5 plus 11/12, which is, we write it as 5 and 11/12. Okay? Now let's do the same thing with the next one here. So we've got 3 minus 2, and that's 1. So down here, I want to work out the fraction parts. So I've got the whole number parts. 3 minus 2 is 1. And I also need to do 4/5 minus 1, sorry, I made a mistake there, minus 1/7. Now, I need my denominators to be the same. So the easiest way is to times the 5 by the 7 and the 7 times the 5. So I'm going to do that here. 5 times 7. If I multiply the denominator by 7, I must multiply the numerator by 7. And here I was going to do 7 times 5. If I multiply the denominator by 5, I must multiply the numerator by 5. So 4 times 7 is 28 over 5 times 7 is 35 minus 1 times 5 is 5 over 7 times 5 is 35. Now that the denominators are the same, I can subtract the numerators and I get 28 minus 5, which will be 23 over 35. So therefore, the whole number bits, when I subtracted them, I got 1, and when I subtracted the fraction bits, I got 23 out of 25. So my answer is 1 and 23 out of 35, or 1 and 23 35ths. Okay, I'm going to go over the page now. This question, I suppose you can think of it as pizzas if you want. So I know I've written a method over here, but I'm just going to do this with drawing. So if I've got 6 whole pizzas, 4, 5, 6, and I want to take away 5/7 of a pizza. Now 5/7 of a pizza is less than 1 pizza. So I'm going to break this last pizza up into 7 parts. 1, 2, 3, 4, 5, 6, 7. And I'm going to take away 5/7. So I'm taking 1, 2, 3, 4, 5. Sorry, I'm taking away 5 out of the 7. So I've got 1, 2, 3, 4, 5, 6 pizzas, and I just want to take away 5/7 of a pizza because it's saying to take it away. So I cut my last pizza up into 7 pieces and I take 5/7 away. What am I left with? I've still got 5 full pizzas and 2/7 left over. Now that really is the easiest way to do that sort of question. Now let's look at this one down here. I've got 7 pizzas, 3, 4, 5, 6, 7 pizzas. And I want to take away 4 and 3/8. So I'm taking away 1, taking away 2, taking away 3, taking away 4 full pizzas, and this pizza here is broken up into 8 pieces, and I'm taking away 3 of them, or eating 3. So what am I left over with? I've still got 2 full pizzas and 1, 2, 3, 4, 5, 5/8 of a pizza. So girls, that really is the easiest way of doing that sort of question. It's to do it by drawing, okay? Okay, now we're multiplying simple fractions. Now, the easiest way to do this, well, is, if you're multiplying fractions, you simply multiply the numerators and multiply the denominators. But if you do that straight away without cancelling first, you're going to end up with quite large numbers. But look, I'm going to do it straight away, and then I'm going to do another method down here. So multiplying two fractions, it makes sense, just multiply the numerators. So 5 times 4 is 20, and 8 times 10 is 80. So I've got 20 over 80. Now I know that I can divide them both by 10. So I've got 20 over 80, that is the same as 2 over 8. Now they're both even, so I can divide them both by 2, and I will get 1/4. So therefore the answer to 5/8 times 4/10 is 1/4. Now the other way of doing it, which is using the cancelling down method, notice that once we've multiplied the numerators and the denominators, we simplify, like we're dividing, here we divided both the numerator and the denominator by 10, got an answer. And then we divided the numerator and the denominator by 2 and got our final answer, and you have to keep simplifying until you get the smallest possible answer. The other way of doing it is to actually do your cancelling down before you start. So you look diagonally and you need to cross off something from the top and the bottom. Now we know that 4 will go into 8 2 times. So if you're thinking of the 4 times tables, you've got 4 and 8. 4 times 1 is 4, and 4 times 2 is 8. So you're seeing how many times 4 goes into 4, and how many times 4 goes into 8. The other thing you can do is pretend it's 4 over 8, and when you simplify by dividing them both by 4, you get a half. So you replace that 4 and 8 with 1 and 2. Same thing with 5 and 10. You think of it, there's a 5 on top and a 10 on the bottom. If you were to simplify 5 over 10, that's a half, because you would divide both the top and the bottom by 5, and you end up with a half. So I'm going to replace that 5 over 10 with a half. Now that gives me, what I've got left over on top is 1 times 1 is 1, and 2 times 2 is 4. Now girls, you do not have to do it this way. I'm happy for you to do it this top method, where you go 5 times 4 is 20, and 8 times 10 is 80. But if you are going to use this method, you are going to have to simplify the fractions that you end up with by dividing them, see what numbers go into them. Clearly, if they've got zeros on the end, you can divide them both by 10. And then if they're both even, you can divide them both by 2. Okay? Now, next question. If you're asked to find a fraction of a quantity or to multiply a whole number by a fraction, remember that any whole number such as 4 can be written as 4 over 1. So I'm going to rewrite 4 as 4 over 1, and I'm going to times it by 3 over 8. So now I'm really just multiplying two fractions. So 4 times 3 is 12, and 1 times 8 is 8. Now they are both even, so I need to divide them both by something. Now look, 4 goes into both 12 and 8, so you can divide them by 2, but you'll find that you'll get 2 more even numbers. Actually, yeah, so it's best to divide them both by 4. So 12 divided by 4, if I do my 4 times tables, I've got 4, 8, 12. So 12 divided by 4 is 3, and 8 divided by 4 is 2. So I've got 3 over 2. Now that's an improper fraction, so it's more than one whole. One whole is 2 out of 2, 2 over 2. So if I've got 2 over 2, I'll have 1 left over. So I get 1 and 1 over 2, or 1 and a half. Okay, now with this question here, what we want to do is, when you multiply mixed numerals, I mean, you know that when you multiply fractions, you have to multiply the numerators and the denominators. When you've got mixed numerals, you've got this 1 and 2 that get in the way. You can't just multiply the 1 and the 2, and then the 3 times the 5 and the 4 times 6, because it just won't work. So what you need to do is to change them both, these mixed numerals, into improper fractions. Now, 1 3/4, that's 1 whole. Now, because we're talking about quarters, that 1 whole, so 1 3/4 really is 1 whole, which is 4 out of 4, and the 3/4 is 3 out of 4. So 1 3/4 is really 7 over 4. So I'm going to replace the 1 3/4 with 7 over 4. Now 2 and 5/6, because we're talking about sixths, each of the 2's, so 1 whole is 6 out of 6, another whole is 6 out of 6, and we've got 5/6. So that's 1, 2 holes, and 5/6. Well, they're all cut into 6 pieces. So I've got 6 plus 6 is 12, plus 5, 17/6. So I'm rewriting the mixed number 2 and 5/6 as 17/6. Now that I've got fraction times fraction, I can just multiply the numerators, so 7 times 17, and you can just do that one on your calculator, girls. And when I do 7 times 17, we get 119, and 4 times 6 is 24. Now, you may need to use your calculator for this. You can, what you can do, let's see how many 24s go into 119. So 24 and 24 is 48, and if you add another 24 twice, you get 96. And I think we don't quite have, I think it's 4 and 23/24. Okay, girls, with this one, you'd really need to use your calculator for this. So what you would do on your calculator is go 119/24 and press the equal button, and you would get 4 and 23/24. Okay. Okay, now we're going to keep going here. I'm pretty sure we didn't get this done last lesson. So we're going to look at these questions now. Calculating fractions of quantities. If you want to find 3/5 of 200 mils, often in maths, most of the time means times. So that's really asking what is 3/5 times 200 mils. Now I'm not going to write the mils in yet, but remember what we were doing before. Girls, you can actually do these with your calculators and go 3 fraction, use the fraction button, 5 times 200 on your calculator. If you don't have a calculator, you'd need to work it out. But look, I really want to just do this particular question here, getting you to practice using your calculator. So you want to go 3/5 times 200. And when you do that, you're going to find that you will get 120 mils. Okay, so I want you to do this using your calculator. With this question, 3/20 of 3 litres. So we've got 3/20 of 3 litres. Okay, girls, sometimes your answers are going to be quite really small numbers, and if you do this, you are going to get a small number. Sometimes what we'd like to do with these questions is to change the litres into mils. Now, every 1 litre is 1,000 mils, so 3 litres will be 3,000 mils. So instead of doing 3/20 of 3, I'm going to do 3/20 of 3,000 mils. So what we need is to use our calculator here. So you go 3/20, put that in as a fraction on your calculator and go times 3,000. And when you do this, you will get 450 mils. Okay. Now, could you please pause the video and try these questions? And when you're done, restart the video and correct them. So we've got 2/3 of 18. So remember, replacing the of with the times, so 2/3 of 18. You can do that on your calculator. Sometimes if they're a little bit easy, you don't have to use your calculator. So we want to go 2 fraction button 3 times 18, and you'll find that your answer is going to be $12. Okay. With this other question here, find 3/100ths of 2 kilometres. Because 300ths is such a small amount of the 2 kilometres, I want to change the 2 kilometres into metres. Now we know that 1 kilometre is 1,000 metres, so 2 kilometres will be 2,000 metres. So the question is going to become 3/100 of means times 2,000 metres. So on your calculator, just go 3 fraction 100, so 3/100 times 2,000, and you will find that your answer is going to be 60 metres. Okay, now we did learn how to do this last lesson, dividing simple fractions. Now, when you divide, when you look at previous questions on other pages, and I'll just turn back here for you, we were seeing that we were multiplying some fractions here, and what we do when we multiply fractions, we just multiply the numerators and multiply the denominators. So what we want to do with this question, with this division question, is actually change it into a multiplication question. Now, I'm going to start off writing the first thing, which is 9/10. Now, when I get to the divide, Oops, I'm all blurry there. All right, I'll just fix that up. So I start off with 9/10. Now we don't divide fractions, we know how to multiply them, so I'm going to change the divide to a times. So just follow these steps here. When you are dividing simple fractions, you need to change the divide sign to a multiply sign, and then we want to flip the second fraction. Okay, so I write 9/10, I come to my divide sign and say, whoops, wait, I need to change that divide to a times. But because I did the opposite of divide and put times, I need to do the opposite here of 3 on 5, which is 5 on 3. So my question now is not 9/10 divided by 3/5, it's 9/10 times 5 over 3. Now remember, when multiplying fractions, you just multiply the numerators. 9 times 5 is 45, and 10 times 3 is 30. Now when you see numbers ending in, actually what I'm going to do, I'm going to rewrite this as an improper fraction. Remember, this is more than one whole. 30 out of 30 is one whole. So one whole would be 30 out of 30, and you've still got 15 left over. So we've got 1 and 15 out of 30. Now 15 out of 30 is just a half, because 15 is half of a 30. So therefore the answer to this question is 1.5. Now let's look at this second question here. This one is a little bit tricky, and it's 3/5 divided by 4. Now the problem is I want to change the divide to a times and flip the second number. But remember, 4 can be written as 4 over 1. So my question now becomes 3 over 5 divided by 4 over 1. So what I'm going to do, I'm going to write the first number, 3/5. I want to change the divide to a times and flip the second fraction to make it 1/4. So my question now is 3 over 5 times 1 over 4. And now we just simply multiply the numerators. 3 times 1 is 3, and 5 times 4 is 20. Okay, it's a little bit trickier, but again, we've got we've got mixed numerals here. So remember, when dividing fractions, you need to change the divide to a times and flip the second fraction. But the problem here is we've got mixed numerals, so we need to change the mixed numerals into improper fractions. Now 1 whole means 7 over 7. The reason we know it's 7 over 7 is that this fraction part is out of 7, so we write the whole number part out of 7 as well. So 1 whole is 7 over 7, and the fraction part is 5 over 7. So 7 over 7 plus 5 over 7 is 12 over 7. So that's what 1 5/7 is. Okay, now looking at the second one, 2.5. Now we know that everything's been cut in half, so you've got 2 wholes here, and each one will be 2 out of 2 and another 2 out of 2 plus 1 out of 2. So that's 1 whole, 2 wholes, and a half. So all the pieces are cut into 2s or halves. So we've got 2, 4, 5 over 2. So it means that 5 over 2 is the same as 2.5. So we rewrite this question as 1 5/7 divided by 2.5 is the same as saying 12 over 7 divided by 5 over 2. Now, just keep this away. Remember, we don't divide fractions. What we do, we change the divide to a times and we flip the second fraction. So it becomes 12 over 7 times 2/5. Now just multiplying the tops, we get 12 times 2 is 24, and 7 times 5 is 35, and that's the answer to that question. Okay, now you might like to pause the video. I want you to try these questions, and please look at these examples before you try the questions. So try 1, 2, 3. This one might be a little bit more tricky for you, but please pause the video, and when you're done, restart the video to check your answers. Okay, let's just check our answers. 3/4 divided by 3/8. Write the first fraction, change the divide to a times, and then flip the second fraction. So that question becomes 3/4 times 8 over 3. Now remember, we're just multiplying fractions, so we just multiply the numerators. 3 times 8 is 24, and 4 times 3 is 12. Now this is an improper fraction. Now remember, 12 out of 12 is a whole, or these actually 12 does go into 24, so we know that 24 divided by 12 is actually 2. The way you can think of it is that 12 over 12 is a whole, and another 12 over 12 is another whole, so we've got 1 plus 1, we've got 2 wholes. Now, as in whole. circles or something. In this question, we've got 3 divided by a quarter. Remember, 3 can be written as 3 over 1 divided by a quarter. So when you're dividing off fractions, if one of the quantities is a whole number, you need to change it to a fraction by putting it over 1, okay? So what we do, we write the first number out, we change the divide to a times, and we flip the second fraction. So instead of 1 over 4, I want it to be 4 over 1. So our answer becomes 3 times 4 is 12, and 1 times 1 is 1. So we've got 12 over 1, which is 12. Now what this question really is asking, it's saying I've got 3 and I'm dividing it into quarters. So if I take 3 full circles and I divide it into quarters, it's like saying how many quarters are there in 3. So if I gave you the question, say 10 divided by 5, you're going to tell me the answer is 2, because I'm saying how many times does 5 go into 10, and it's twice. So how many quarters go into 3? So I've got 3 full circles. This is a way of looking at it with diagrams. Dividing it into quarters, how many quarters do I have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, which is the answer that I got there. Now in this question, remember, you need to change your improper fraction, your mixed numbers, to improper fractions. Now you've got 2 wholes and each whole is in 5 parts. So you can work it out down here. So 2 4/5. Each whole is 5 out of 5, and the next whole is 5 out of 5. And, sorry, you can't see that. And this 4, and you've still got 4/5 left. So I'm changing 2 4/5 into a improper fraction. So 5 out of 5 is 1 whole, another 5 out of 5 is a whole, and I've got 4/5 there. So now that they're all fifths, I can add, and I can say I've got 5, 10, 14 fifths. So I replace this 2 4/5 with 14 fifths. I need to do the same with the 1 3/4. Now, because we're talking about quarters, I say 1 whole is 4 out of 4, and 3/4 is 3 over 4. So denominator is the same, so I've got 4 plus 3, I've got 7 over 4. So I change my question, and instead of writing 2 4/5 divided by 1 3/4, it becomes 14 over 5 divided by 7 over 4, because that's what 1 3/4 is. Now remembering, when we divide fractions, we change the divide to a times, and then we flip the second fraction. Now you can do some cancelling if you want between the 14 and the 7. Otherwise, when you come and multiply these numbers, your answers are going to get quite big. So remember, you try and look if you can do some cancelling between the 4 and the 5, or you pretend here that the 14 is over the 7, because that's on the top and that's on the bottom. Now, if you had to simplify 14 over 7, you know that 7 goes into, you can divide them both by 7, and 7 goes into 7 twice, and 7 goes into 7 once. So this 14 over 7 can be simplified to 2 over 1. So then that becomes 2 times 4 is 8 over 5 times 1 is 5. And the numerator is bigger than the denominator. So we've got 5 out of 5, which is 1 whole, and 3 left remainder over 5. So it becomes 1 3/5. The other way you could have done it is do 14 times 4 without this cancelling, and you would have got 56 over 5 times 7, which is 35. But then you need to simplify that. Now 35 goes into 56 once, and I think you've got 21 left over out of 35. But the thing is, then you need to simplify that fraction, 21 over 35, and you can divide them both by 7, and you'll get 3/5. Now, doing it this way is a little bit more complicated because the numbers can get quite big. Okay, girls, for those that had already done the first page of fractions, you can stop the video now. But for those that weren't here last lesson, I'm going back to the first page on fractions. Actually, what I'll do, this video is getting quite long. I will do the rest of this in another video. Okay.